Okay, so in this video, I want to sort of lay out the background or the I guess some information, some things about inverse functions and prerequisites. That's the word I was looking for. And so one of the prerequisites for inverse functions is knowing what a one-to-one function is. And so I have a definition here, right? It says a function f is said to be one-to-one if for any choice of numbers x1, x2, so different x's in the domain, you must have different function values. And so as an example of something that is not one-to-one, kind of show like a counter example here. Let's think about the function y equals x squared, right? Because if you look at y equals x squared, which is just a nice little parabola here, right? You have a function or you have a graph that is definitely a function, right? So it definitely passes the vertical line test. But if you look specifically at 2 and at -2, right? Those are both different x's. The problem is both 2 and both -2 give you the same y value, right? So f of -2 equals f of 2. Which is equal to 4. So that doesn't follow the guideline for being a one-to-one function. So this is not one-to-one. And again, this idea of one-to-one, you can also think about as soon as you've paired some x to some y, you can't use that y anymore. That y can only be used for one x. And so if you really think about like your domain and your range, like in terms of a set of numbers, you're pairing one x with one y, and that's it. One x with one y, one x with one y. So that's where it gets its name, one-to-one. Now, you can take functions that are not one-to-one, like this parabola, and narrow down the domain. So like if I said, y equals x squared, but let's let only x be greater than or equal to 0. In other words, you only take the right side of your parabola. So what if this was my function, just that part of it, right? So if it's just that part of it, that means that, for every one x, there is only one y. So by restricting the domain, we're able to create one-to-one functions, okay? Now, there is a test too, similar to the vertical line test, right? The vertical line test allows us to draw a vertical line if we want to see if it's a function itself, but then there's also a one-to-one function test, which is the horizontal line test. So the horizontal line test, write it out, horizontal line test. If you can draw a horizontal line across your function and it hits more than once, you fail the one-to-one test, right? So you have to be able to draw a horizontal line anywhere for it to pass the one-to-one test. And again, that's sort of, I can see this parabola, right? Without the restriction, it's going to fail the horizontal line test. So horizontal line test allows us to test for a one-to-one function. So, some of these things are asking like, okay, which of these are one-to-one? And right away, based on that horizontal line test, right away, I can eliminate B, because think about B, it's a quadratic that's been pulled down 4 units. So it clearly fails, right, the horizontal line test, because there are many, many points that I could draw the horizontal line, right? Basically anywhere above the vertex, it will not pass. So this is not a one-to-one function. Okay, so that's not true. Okay, but now -6x minus 4, like that's just a linear function. And thinking about a linear function, no matter what your linear function is, right, it's going to pass the horizontal line test because, everything is linear. So there's -6x minus 4, no matter where you draw a horizontal line, right, it's only going to intersect once. For every y, there's only one x that goes to it. So I would say, yep, for that one. Okay. Now, piecewise function or pointwise functions here, you have to check. For every x, does it go to just one y? So what you should maybe look at first is like the y's. You have a -2, you have a 0, you have a -1, and a 9. So there are no other, since there's no repetition there, only one x is going to that y. So then I could say, yes, this is a function as well, or yes, this is a one-to-one function as well. Okay. So now, but if I look here at the next example, I have 0 going to 1. I have 2 going to 1. I have 4 going to 1. I have 6 going to 1. Right? I have 8 going to 1. So all these values are going to 1. And in fact, if you were to draw this graph, it's like a dotted line, but it's a dotted horizontal line, right? Think about that. Like, oops, that's a really thick XY axis. Let's go here and let's make it thinner, I guess. Okay, so right, if you go to 0, 1, and then 0, 1, 2, 1, 4, 1, 6, 1, 8, 1. I mean, they all have this horizontal line. Even though it's not connected, it still fails the horizontal line test. So the answer is no. Okay, so I don't know if you know this function or not. It's called the greatest integer function. So the greatest integer function is basically a rounding down function or a floor function. It's the integer that is less than or equal to whatever you put in there. And some textbooks denote it in this fashion. So we're going to talk a little bit more about this particular function later on. So I'm going to kind of table this right now, but this is definitely not a one-to-one function, because if I say, okay, well, what's f of like 1.567? The greatest integer that's less than that number is 1. But then if I say, well, what is f of 1.4? Well, the greatest integer that's less than or equal to that is also 1. So anytime you take two separate x's that give you that give you the same y, you're not a one-to-one function. So this is definitely no. But like I said, we'll talk more about this function as we move on in this chapter. Okay. For part F, absolute value of x minus 3. So I'm shifted to the right 3, and I draw my absolute value graph, but clearly, right, that function does not pass the horizontal line test. So that is not a one-to-one function. Now, G is interesting because initially you might think, oh, it's a parabola, fails, right? But look at, we've restricted the domain. X is greater than or equal to 1. So if I were to graph this function, the vertex is right 1, up 7. So right 1, up 7. And I would draw this, but then notice it says, oh, let's let x only be bigger than or equal to 1. Which means I don't take this side here. This side of the parabola is missing. So then I could say, well, wait a minute. Now that I only have half of this branch because I divided it, right? Because I divided it at the vertex. Yeah, it does pass the horizontal line test because I've restricted the domain. So this one is definitely a yes. Okay. And then I'm seeing, this one here, this is a rational function. Like we just graphed these last unit. So there's a vertical asymptote at -4. There's a horizontal asymptote at +1. And then when you graph this, you end up getting like these two branches. And, again, you'll pass the horizontal line test because there's no loops, like there's no quadratics in that one. So that one is definitely a yes. Okay. A cubic without any other kind of transformations. Oops, sorry, my eraser's not working. Yeah, that's a one-to-one function as well. Right? Think about that. The graph of your cubic does this, and for that one instant, you are that horizontal line, but just for that one instant, or I should say like a horizontal tangent. So yeah, that is yes. Now, not all cubics are going to be one-to-one functions, because you could have a cubic function, like maybe you had a few more twists in it, something like this. So if all of a sudden you start transforming a cubic, then there's no guarantee that's going to be a one-to-one function. Okay. I just gave that away, so that's good. Hopefully you remembered. But then our last one here, it's a parabola, but they're giving us a restriction of the domain. So we should probably anticipate that it's probably going to be the vertex, right? So let's complete the square just to check. So we have x squared plus 16x, half of that. 16 is 8. 8 squared is 64. But then we immediately subtract 64. And I wonder if that's a Mr. Brown typo. It would have been a lot cleaner if that was a positive 63, but oh well, it's okay. So that's x plus 8 squared, and that'll be minus 127. So the vertex is at negative 8, negative 127. And notice that we're restricting x to be less than or equal to negative 8, which is that vertex value. So we are just taking half of the parabola. And it's the left half of the parabola this time because it's less than, but it's okay. So if you go negative 8 and then like negative 127, so obviously not drawn to scale, and and you draw your parabola, since I just want less than or equal to negative 8, it's just going to be this much of the parabola, right? We don't have the remaining half. And when we restrict our parabola straight down the middle like that vertex, then yes, it can be, yes, it can be a one-to-one function. And then we already said, what is that one-to-one function test? It's the horizontal line test. Okay, so in order to really get a good grasp on inverse functions, which will be the next video, we really need to know what does it mean to be a one-to-one function. And so as a summary, a one-to-one function means for every y, only one x would map to that y value. Okay, so very good. Let me know if you have any questions. Otherwise, then we'll look at the next video.